right, a nice big welcome for our next speaker, Erika from Agronomic IQ, who is going to talk to us about how to properly design your HVAC system. So, Erika, over to you.
Okay, thank you very much. For those of you on the other side of the pond, good afternoon. And for those of you in North America, like me, good morning. My name is Erika Summers. I'm with Agronomics IQ, and today I'm going to discuss you can't design what you don't know, inputs for proper CEA HVAC engineering. So to start, I am the Business Development and Sales Manager for Agronomics IQ for indoor produce. I have been in the CEA industry for about 8 years. 3 years I was an independent consultant, and then I joined Agronomics IQ because I'm very passionate about HVAC equipment and making sure that this application is correct into this space. And by degree, I'm a mechanical engineer. So real quick, a kind of a high-level overview on Agronomics IQ. Agronomics IQ is a division of Dehumidified Air Solutions. Dehumidified Air Solutions has been doing pool dehumidification since the 70s. So they've been around for a long time and have worked in high humidity, high temperature environments for the duration of that time. Our first venture into CEA was in 2014. Since then, we have 240 grow sites across North America, 1,600 units installed in the field, and just a lot of experience in this kind of space. Most of it is in cannabis, but also in leafy greens. And then kind of a higher level view, we are owned by the largest privately held manufacturers in the world, so Madison Industries. That's all to say, we've got a lot of incredible backing behind us. We are CEA focused, and we have the intention of being here and being partners with this industry for a long time moving forward. Now, everybody watching this presentation is probably very familiar with what CEA means, but I wanted to put up this slide to kind of highlight. Controlled environment agriculture is managing the indoor grow environment and key factors like temperature, humidity, light, CO2, and the nutrient delivery to plants for optimal plant growth. The challenges that we have in selecting HVAC equipment is HVAC equipment is responsible for the humidity mitigation and the temperature management in these facilities. Now, HVAC equipment, anybody that's been in the CEA space knows that the HVAC equipment is kind of that silent killer when it comes to budgeting for these facilities. It is usually one of the much larger expenses. And it usually also requires things like power upgrades in conjunction with lights and stuff like that. So it's a big capital expense. And traditional HVAC equipment is not necessarily designed for these kind of applications, because traditional HVAC equipment is designed for temperature control, not necessarily humidity control. So the two detriments that you will see in these kind of applications, or the two worst case scenarios, is undersizing equipment, which will lead to lack of environmental controls in your space, or oversizing equipment, which will add unnecessary cost. So gathering and conveying the correct information to your MEPs, your specifying mechanical engineers, and the equipment providers is essential for proper unit selection and operational success. Now, the reason why I really wanted to give this presentation in this manner is because in the last several months, I've been talking with a fair amount of mechanical engineers that are venturing into this space for the first time. And they're designing these facilities, but I'm spending a lot of my time trying to explain to them what all goes into these facilities. I think that when we spend so much of our time in this sector, we kind of become blind to the fact that somebody that's coming into CEA doesn't understand all of the different pieces of equipment, all of the different growing procedures, just everything that goes into one of these vertical farms or one of these grow rooms. And like I said at the beginning, or the title of this presentation is, if you don't know what to take into account or what to look for or what to ask for, then you don't know what you don't know. And that's kind of how there are misses that are happening in these facilities. So when thinking about a grow room, I kind of break it up into two different sectors. One is what in this space is causing heat, or in HVAC terms, the sensible load. So everybody knows the lights are one of the huge heat inputs, but things like fans, motors, pumps, those all will actually put heat into the space as well. Another one is if you've got germination racks or heated germination racks, those will put off a lot of heat. Seeding equipment, harvesting equipment, and CO2 burners. That's all putting heat into this space, and that all needs to be taken into account when you're doing the calculations of what that heat load is in the space and what your HVAC equipment needs to handle in order to keep that good room environment. Next is what is creating humidity in the space. So when plants are growing happily, they're only retaining about 5% of the water intake that they have in their cellular structure. The rest of it is going into the environment. The happier the plants, the more nutrient uptake they have, the more they're putting out. So we want them to be doing this as much as possible, but in that they are putting out a lot of humidity into the space. The second is in vertical farms, I see this a lot. If you've got recirculating nutrient systems and you've got open troughs for drains or inputs, and those open spaces, open bodies of water are coming in contact with the light, probably growing algae, but you're also getting evaporation. So understanding what the plant count is, how many are, what the transpiration rates are, how much open water surface area do you have, all is super important in calculating that humidity or the latent load. Humidifiers are also something that, this is something that we see a little bit more in the cannabis application, but it's something that I wanted to mention. If you have a room of smaller plants that need humidifiers in earlier growth stages and not in later growth stages, that's again information that needs to be conveyed to your MEP and your equipment provider, so that they're ensuring that they're selecting the appropriate equipment. Now, communicating this information, I spend so much time, kind of, like I said, coaching the MEPs that I work with on all of the questions that are necessary for them to get an accurate grasp of what is going on in these grow rooms, so that we can design systems appropriately and we can select equipment appropriately. So the initial information that they need is basic layout information. What are the dimensions of the grow rooms? Obviously, what are the rack configurations, etc. They also need to understand facility information and limitations. CEA facilities require a significant amount of power. If there is power constraints, we need to know what those are before we're going down the rabbit hole of selecting different equipment, because if you've got power limitations in your facility, you might need to buy the more expensive equipment that is the most energy efficient for your application. You also need to know things like building heights. I was working on a project where the building height was already maxed out and we couldn't put equipment on the roof based on the local jurisdiction, so we had to put equipment around the perimeter of the building. So understanding, or if I've seen also people that come in for these kind of facilities that are like, hey, I'm on the second floor of a 4-story building. That's the information that we need to know. Is there roof access? Do we have availability around the perimeter? What is the power? All of that goes into the discussion and the figuring out what is the appropriate equipment. Next is, what are you growing? The strategy behind designing a facility for a bunch of microgreens versus lettuce is different. And I know in this space, everybody loves to come in and say, well, I want variability. And as an equipment provider, I always explain that variability is just adding unnecessary cost to your facilities. An piece of equipment that can go lower temperatures and humidity and higher temperatures and humidity is probably going to be sized with extra cushion just to make sure that it can meet those ranges. And having those ranges is taking money out of your pocket or your capital expense for the facility. So having an idea of what it is you want to grow allows us to estimate transpiration rates, but and gives us accurate understandings of what temperatures and humidity targets you want for your environment. And then kind of as we were discussing before, what is creating heat in the facility and what is creating humidity in the facility? So going back to the facility makeup, the inputs, lights, fans, pumps, things like that. If they are being provided electricity into the space, give us the watts of the lights, and then we can do the calculations of what the sensible load is. Things like CO2 burners from the manufacturers, you can get BTUs per hour. For the inputs and humidity, again, it's if you know what you're growing, we can kind of have rules of thumb of plant transpiration rates or estimated plant transpiration rates. Or if you're working with a racking provider, I always highly recommend having the discussions of, hey, what data do you guys have of when this rack is fully populated with this cultivar? In one day, how much nutrient replenishment is necessary throughout the growth cycle. Some can be in liters, some can be in gallons, but real world information is really helpful for us in making the estimations, because if it is a racking system, like I said, that has a whole bunch of big open drains, that's going to put off more humidity into the air. So if you can gather that information from them, super helpful in making these calculations. Once all that information is gathered and provided to your MEP in conjunction with us or on their own, depending on how familiar or comfortable they are, will do different calculations. They will come up with the latent cooling load and the sensible load in the space based on the inputs provided. And when they have the latent load, which is, like I said, that humidity load, and the sensible load, which is a temperature load, they will give us, the equipment vendors, that information plus the grow room condition targets. And we will go back and run specific tests with our equipment to see where we can meet that load and what equipment we will present for meeting those desired room conditions. Now, different equipment, in HVAC equipment, tonnage is kind of the normal way that people would calculate the sensible load. But because we are dealing with latent and sensible in these kind of applications, 70 tons to one supplier can meet the load versus 55 tons with another supplier. So don't go based off of tonnage. Go based off of what is their capacity to handle both the latent and the sensible load. So don't do tonnage to tonnage comparison. Do it based off of what is based on the room conditions and the loads, what can it manage? Once that is done, the equipment provider will run our load selections, come back to the MEP, and present our equipment selections. So the graph that you see here on the right is one of my leafy green growers. If I was to say, like, for a real world application, this is kind of as close as we can get to a really good selection for this facility. They have one unit with multiple compressors. And as you can see, the temperature is very consistent. The humidity has a little bit of swing, but also is very consistent. And if you look down at the bottom, that's kind of where the compressors are running. These compressors are running comfortably. There's a little bit of intermittent turning off and on. So there's a little bit of extra capacity, but this is perfect for this facility because going into the warmer seasons, this is kind of spot on of what you want your environmental control or your controls graph to look like of how your facility is running. Now, Agronomics IQ, we make packaged units with reheat or 100% hot gas reheat. But I would be remiss if I didn't explain the 3 different kind of systems that are available for you in your facility. First is something that we call decoupled systems. This is kind of your traditional standard packaged HVAC equipment with standalone dehumidifiers. So basically you have units on the roof or units wherever they are placed that are just handling the sensible load or that heat load in the space. And then you have dehumidifiers that are running in the space that are handling the dehumidification. Now, the challenge with this is you're trying to balance both pieces of equipment, and it is not the most energy efficient. Upside, it's a lot faster application, but it isn't a true engineered system. Our units, as I said, are packaged units with 100% hot gas reheat capacity. This means all of the cooling, all of the dehumidification is done in the unit. And based on the configuration of the unit, we are also able to get free hot gas reheat. So that air, once it is cooled and dehumidified, can then be brought back up to appropriate room space temperatures and put back into your facility. So you're not overcooling a space because you're trying to do the dehumidification. These units are more expensive typically than the decoupled units, but you're going to have an engineered system that is actually has tighter controls in your facility. The third option is chillers and a chiller and a boiler combination. So air handling units that use chilled and hot water from a central plant. This is a great application, but these chillers, boilers, it takes a lot of engineering. The install cost is higher. There's a lot of intricacies to this type of application. So it's really case by case. What is the best evaluation for your facility? And when you're comparing, if you get a proposal with the different options, really look at capital cost, equipment lead times, installation cost, room control accuracy, scalability, redundancy, maintenance, energy usage. All of these things are things that need to be considered when you're deciding between the 3. And I just remember, so decoupled systems also can be paired with desiccant units. Just another option that you have. So next, I want to talk about some just additional design considerations. Like I said, I love educating this industry about HVAC systems, all of this stuff, because this is where we're seeing a lot of misses happen. And I think it's just because of lack of knowledge given in this sector. So when you are thinking about your HVAC system, there are 3 ways to approach airflow or your air strategy in your grow room. Your HVAC system is going to provide your dehumidification and cooling capacity, and it's going to be input into your room. But if you've got multi-tier racks that are like this, I hate to break it to you, but it does not matter what duct system in the world you have, air doesn't go in turns. So if you've got multi-tier racks with tight spacing, things like that, really consider your airflow strategies. How are you getting air, all of that process air that is being input by your system to your plant, and then how is all of that air getting pushed back to the returns so that you have a homogeneous room environment? Next, view your room as a system. One change can have a cascading effect. If you double your watering rate, or you go to a crop that is much higher temperatures and much higher humidity than what you originally planned for, check with your mechanical engineers, check with your controls contractor, check with your equipment provider, just to make sure that doing something like that doesn't knock you out of the capacity of the units that you have for the space. Also, I see this a lot in the cannabis industry, not so much here, but it is worth noting. If you go from a single tier to a multi-tier rack, you are doubling the load in the space. So you will probably lose control. Just communicate as much upfront as possible. Second, when you're considering what your HVAC system needs to be, redundancy is key. These HVAC units, depending on the system that you use, most of them have compressors. It is not a matter of if a compressor fails, it's when a compressor fails. And that's not saying that anybody in the industry is using bad compressors. That just means that these units are run at full capacity all the time, 24/7. So having a strategy of if a compressor goes down, having extra compressors on hand, having a mechanical contractor that can come in and service these compressors so that there's a quicker turnaround time, having multiple units servicing a space. So if a unit goes down, you can turn off all your lights and still keep the space somewhat cool and dehumidified with another unit until the unit that you have is fixed. Just think through what can go wrong and what is your backup plan, and then have a backup plan for your backup plan. For these spaces, make sure that your controls are CEA specific, meaning that they not only manage the temperature, but the humidity as well. Typical HVAC systems will just manage the temperature. As I said before, understand that these units are running, if your operation is running 365 days a year, these units are running 365 days a year, 24/7. So think about how installation for these units is going to be, and then think about the maintenance. You don't buy a Ferrari, drive it at 100 miles an hour for hours and hours and hours, and then don't do maintenance like an oil change on it. These units are the same thing. They do need maintenance at different intervals. So just think about that. Think about how your technicians can do maintenance. If these units are really impossible to get to or there's struggles, you're not going to get the maintenance you need, which will kind of have, again, that cascading effect that you might have the units go down and mess up your operation. Now, as I said before, Agronomics IQ, we do packaged units. So we have two different type of units that we use. Our Evolution series, which is our 4 to 32 tons. And it has a 20 to 170 pounds per hour moisture removal. Like I said, don't just go off of tonnage, go off of how much moisture removal and how much it meets your space. These units are typically, they're smaller split system units. So these units are really great for any sort of retrofit application where you can't put equipment on the roof, or you have long runs between where the unit is and where your condenser can be. We do a lot of retrofits with these units. Compressor wall is 10 to 128 tons. These units are our bread and butter in the cannabis industry, and they are also fantastic for larger grow rooms. 20 to 730 pounds per hour. These units are big industrial units, purpose-built and designed for CEA spaces. And then our dry coolers that are used in conjunction with our compressor wall and our Evolution series. So real quick, just a highlight about our compressor wall units. These are, again, our bigger units that are required to larger grow rooms. One of the competitive advantages that Agronomics IQ thought of when we were designing units for this space is ease of maintenance. The compressor wall is comprised of 2 to 9 compressor module pods, we call them. So when you are on site or when installation is happening, all of your refrigerant is contained in these pods. And if you ever had a compressor go down, you could literally have somebody come out, pop out a pod, replace the next pod in about an hour and a half to 2 hours with 2 people, and you're back up and running. This is fantastic for that redundancy and just making sure that you are protecting your facility from any sort of downtime that could be detrimental to your survival, basically. These units are 100% modulating hot gas reheat, which just make them ideal for the CEA industry. So in summary, please, please, please give as much information to your MEPs and your HVAC equipment vendors as possible about your growing environments. I would say if they are not asking as many questions as possible, please verify that they understand the application and they're thinking about all of these things. Like I said, whenever I get on calls, it's long investigative questions, but it's to your for the customer's sake, because we want to make sure that we're encompassing everything to make sure that the equipment selection is correct. Consider when you're going through your grow rooms, like I said, consider what is creating heat in the grow rooms and consider what is creating humidity, and kind of convey both. Like, hey, these are all of our heating applications and these are all of our humidity causing applications. Remember to prioritize performance and capacity over tonnage numbers. So if two equipment vendors are coming and saying, hey, we both have two 70-ton units, make sure that the performance at your conditions is meeting what your load is, because it's not always apples to apples comparison when it comes to that kind of outputs. Evaluate what your level of risk / redundancy you are comfortable with. If you are super tight on budget, tell that to your MEP. Say, hey, I understand that one unit servicing our grow room is not ideal, but we have CapEx budgets that we need to meet. And we are accepting the risk that if this unit goes down, we're going to have these backup plans in place. If you have it, multiple units servicing a room are always better. But again, it's up to you. What is your capacity for your capital cost, and what is your backup plans for redundancy?
And sorry, Erika, I'm gonna have to bring you to a close very soon. So if we can just
sorry,
make our way.
I get very passionate.
Sorry,
no, of course. And then real quick, if you have any, we as Agronomics IQ, we really do try to put as much information out as possible for you to empower anybody that's working with MEPs. So go to our website, give it a look. And with that, thank you very much.
Thank you so much, Erika. I'm afraid we have run a little bit over, so I'm going to have to skip the questions on this occasion. But if you do have questions for Erika, if you want to know about HVAC systems, if you want to know about doing it properly, get your information together, get in touch with her. I'm sure she'll be happy to help you think through all of these things and get it right the first time, which can't be overstated, the importance for sure.
Absolutely. Thank you.
Thank you very much, Erika. And yes, we will be back momentarily with our next speaker. Thank you again.
Great. Thank you.